Hey, Chem 20 IBs. Just a quick review quickly of the three different types of solution chemistry. The IBs are about a half a day behind the regulars when COVID-19 occurred. So I'm going to go over percent volume, part per million, and moles per liter kind of quickly because the one class has seen it, and IBs you've seen the first part of this. So percent volume is basically solute over solution times 100. Now there's three different types you can do. Your solute could be measured in milliliters, your solute could be measured in grams, and as well your solution can be measured in milliliters or also in grams. So you can have volume, which is a volume on top and a volume on the bottom. You could have mass volume, MV, or WV, weight volume, which is grams on top and milliliters on the top, the bottom. Or you can have WW, weight, which is grams on top, grams on the bottom. This question is a volume solution, so it's a VV. So if we look at this one, we're trying to solve for the hydrogen peroxide in it, which is the active ingredient and thus the solute. So this whole thing gives us percentage volume within volume. Now, if I set up my formula, it looks like I don't know the solute, which is X. The solution is 250 liters. I can change that to milliliters if I want, or leave it in liters. Times by 100 is equal to 30%. So I have to rearrange this for X. I'm going to divide both sides by 100. That'll cancel out. Now I have X over 250 is equal to 0.3. 30 divided by 100 is 0.3. Then I'm going to times both sides by 250, 2.5 liters, times by 2.5 liters, and 0.3 times 2.5 gives me 0.75 liters. Had you turned this into milliliters, you would just get 750 milliliters instead of 0.75. Okay. All right, next question. It says, if 3 grams of K2CO3 is dissolved in 450 milliliters of water, what's the percentage weight? Okay, so this is a weight within volume. So solute over solution times 100 is equal to WV, so weight volume. So what do we know? Well, our solute is 3 grams. Our solution is 450 milliliters times by 100. Now, it's a little ambiguous. Would those 3 grams give you 3 more milliliters of water? That's a good question. I don't know. We could calculate this a couple different ways and say, yeah, if we put 3 grams in there, you would get 453 milliliters. Let's see how close of an answer we get there. So 3 divided by 450 times 100 to really 1 sig fig. That's 0.7%, and 3 divided by 453 times 100, I get the exact same thing. So in this case, it didn't much matter. All right, last one says to make a saltwater concentration, we have 32 WV, 32% WV. How much salt would you need to create 5 liters? Okay, so we go, let's do solute over solution times 100 is equal to WV, weight volume. We don't know the solute. Now, to be fancy, I'm going to turn the liters into grams. So I've got 5,000 grams times 100 is equal to 32. So I got to solve for X. I'm going to divide both sides by 100 to get rid of 100. Then I have X over 5,000. Oh, that should actually be milliliters. My bad. We'll just change that to milliliters. Okay, is equal to 0.32. Now I'm going to times both sides by 5,000 milliliters. Cancel out. So 0.32 times 5,000 gives me 1,600. Now, what unit is it? It's a weight volume question, so that's in grams. Had you kept everything in liters, that would now be in kilograms. You'd have 1.6 kilograms. So that is a volume percentage questions. It's literally just how much do you have divided by total times 100. Now, part per million is a little bit tougher. Chem 20 IBs, we've covered a little bit of parts per million. So let's just try this one out. Part per million formula is solute over solution times a million. Okay, that's the formula for part per million. Part per million is solute divided by solution times a million. That's your formula. And both the units on the top and the bottom need to be the same. There's also a shortcut, which is really cool, is if you can keep the solute and the top in milligrams and the solution in the bottom in liters, that's already a part per million. So you can use this formula, or you can go a milligram divided by a liter. That gets you parts per million. You don't have to times it by anything because these are already a million times different in scale. So really it's up to you. Just for the shortcut crowd, you can pick what you want. I'm going to use the formula. So reading this question, we've got 4.5 liters and 2.51 grams arsenic. Okay, so how do I solve this? Well, the solute will go as 2.51 grams. And the solution is 4.5 liters, but I have to keep my units the same. So that's 4,500 milliliters. And I'm going to times that by a million. 2.51 divided by 4,500 times a million times by 10 to the 6. I get to 3 sig figs, 558 part per million. So what's the unit for part per million? It's part per million. It really doesn't have a unit because it's explaining that you have 558 parts of arsenic per million parts of arsenic. So really this ratio is the same. Another cool thing you can do with parts per million, if you really want to, is you can set up a ratio because parts per million is just 1 part per million. So you could set that up and solve for X. That's another way you could solve part per million. Might be faster actually. Okay, let's try the next question. We've got, there's some secrets down here. Ooh, okay. So this question says my bottled water was 10 part per million of fluoride and I drink it. My 1 liter bottle, what mass of fluoride was I ingesting? Okay, so let's get our tinfoil hats on and talk about fluoride. Fluoride is put in water to keep your teeth safe. Anyways, so let's set up the formula. Solute divided by solution times 10 to the 6 is equal to part per million. Perfect. We don't know what's in the water, so that's X. We know that we have a 1 liter bottle. So let's just change that to milliliters. So we're solving for grams. And we're going to times that by a million. And it says that the fluoride is in 10 parts per million. Perfect. So let's divide both sides by 1 million. Okay, I'm going to run out of room. That is X over 1,000 milliliters is equal to, oh man, what's 10 divided by a million? That's a very small number. 1 times 10 to the minus 5. 1 times 10 to the minus 5. Okay, now how do we solve for this? Well, we got to get rid of 1,000. So I'm going to times both sides by 1,000. Okay, times that by 1,000. Boom, I get, I hope this is right, 0.01 grams. You can check yourself before you wreck yourself too by going backwards and double checking that. If 0.01 divided by 1,000 times a million, that should be equal to 10, and lo and behold it is. Okay, there's your question. Now, if you want to use that cool little ratio thing, coronavirus. Okay, if you want to use that ratio thing for this question, another thing you can do is go, oh, what the heck, 10. Okay, 10 parts per million is literally like saying you have 10 grams per million milliliters. And that's equal to, in our ratio, we have a 1 liter bottle, which is 1,000 milliliters over X. Some people really like that ratio and they cross multiply and divide. You're going to get the same answer of 0.1. But that's what 10 parts per million means. 10 parts per million means 10 parts in a million parts of something else. Okay, so this is a quick little recap of parts per million and percentage volume. The second video is going to be of molar concentration, and the IB students, you haven't seen this yet. So that's why it's going to be in 2 separate videos.